Dun, dun, dun. Question 6. So you've spent all that time working on 1, 2, 3, 4, and 5, and then you look and say, okay, here's question 6. So let's look at this. The first thing says, Emma's moving to a large city and is investigating typical monthly rental prices of available one-bedroom apartments. She obtained a random sample. Yay, good for you, Emma. A random sample of 51 bedroom apartments taken from a website where people voluntarily list available apartments. Oh, there's a question. There's an A. Some of you missed this. Describe the population for which it is appropriate for Emma to generalize the results from her sample. What is the population she studied here? Where's the random sample? 51 bedroom apartments taken from a website where people voluntarily list available apartments. So I wrote, the population of interest is one bedroom apartments taken from a website where people voluntarily list available apartments. So there's a partial. You should be able to do that. It was given to you. Then our next part says, okay, so we have a distribution of those 50 rental prices. And they're labeled here in the histogram from somewhere around $1,600 all the way up to $5,200. Notice there's a couple of gaps here. This is strolled out to the right here, to the right. Emma wants to estimate the typical rental price of one-bedroom apartments in the city. Based on the distribution shown, what is the disadvantage of using the mean rather than the median as the estimate of the typical rental price? Well, the obvious thing right here should be this is skewed to the right. The vast majority is right here. These are outliers. This is way out there, okay? That $5,200 one, whatever it might be. Now, notice that's not the exact price. These are intervals. These are intervals, so it's something around that price. These are medians of that sample. Okay, so what's the disadvantage of using the mean rather than the median? Since it is skewed to the right, that means if it was normal, then my mean and median would be together. But since it's not approximately a normal model, it is skewed to the right, my mean is pulled because of these outliers out here, these higher numbers, my mean is pulled away from my median. So the median would be better to describe it since the distribution is skewed to the right, the mean will be larger than the median. The median will be a better representation of the typical rental prices. That's all you got to write. The mean would not be a good representation of the cost because it's farther to the right. It's larger. Now, this is 2 parts you should have gotten so far. And these 2 are together, so that could have been a 1 that you got on question 6. Now, part C here is in and of itself a point. Instead of using the median, the sample median as the point estimate for the population median, Emma wants to use an interval estimate. However, computing an interval estimate requires knowing the sampling distribution of the sample median for samples of size 50, all of the samples of size 50. Emma has 1 point, her sample mean in that sampling distribution. Using information about rental prices that are available on the website, describe how someone could develop a theoretical sampling distribution of the sample median for samples of size 50. So what she would need to do, Emma would need to generate all of the possible samples of size 50 one-bedroom apartments and the median of each sample, and then create a distribution. She would have to generate all of the possible samples of size 50 of the one-bedroom apartments and the median of each sample. Okay, so there's A, B, and C. And if you could answer 2 of those, you could get at least a point on this. We've still got some other parts that, and then one of these other parts is very simple, but we'll get there. So let's look at the bottom of the page. Emma does not have the resources to develop the theoretical sampling distribution. So she estimates the sample distribution of the sample median using a process called bootstrapping. In the bootstrapping process, you don't have to do this. You don't even have to understand really what bootstrapping is. A computer program is going to do this. Computer program is going to take a sample with replacement of size 50 from the original sample. So they're going to start taking samples of all this. And then going to calculate and record the median of the sample. Then it's going to repeat the process to obtain a total of 15,000 medians. So they're going to do a total of 15,000 medians. And here is the readout of those 15,000 medians. There was 1 at this price. There were 13 in this price, had a median of this. 18 had this median. So the bootstrap distribution above provides an approximation of the sampling distribution of the sampling median. A confidence interval for the median can be constructed using a percentage of the value in the middle of the bootstrap distribution. In other words, if you drew this distribution, we would try to find the middle of it. And it says, use the frequency table to find the following, the 5th percentile. Well, there's 15,000 samples here. The 5th percentile would be 5% of the 15,000. So that's the 750th number. You multiply 5%, the 5th percentile times 15,000. That's 750. And then you think, okay, well, what's the value of the 750th number? Well, I start adding these numbers up, and when I get to 136, I get 408. And then I notice my next number is 1899, 1,899 at 2,500. So the 750th number would fall in this interval. So that value is $2,500. Then I say, okay, well, what's 95% of 15,000? Well, that's 14,250. Well, that's 750 less than 15,000, right? Makes sense. So I start at this spot and I start adding until I get 750. Again, I want the 750th number going backwards. Well, I start adding and I get to here and I get 188. Well, plus this 700 in here makes 888. So the 750th number, or the 14,250 if I come this way, falls somewhere in here. That's $2,950. This should have been easy to do. The 5th percentile is 5% of that number. The 95th percentile is 95% of those numbers. Next question asked. Find the percentage of bootstrap medians in the table that are equal to or between the values found in Part D. So again, I summed these numbers, that's 408. I summed these numbers, that's 188. Bottom 5, top 5. So that's these numbers here are between the 5th percent and the 95th percent of these numbers. So I took 408 plus 188. That's 596 numbers on the outside of my interval up here. So 15,000 minus 596 is 14,404. Well, 14,404 divided by 15,000 is 0.96. It's 0.9603. I'll go ahead and put the 03 in there. So this interval here is about 96% of my data. So it's a 96%. It's a 96% confidence interval. Now, they also said, if you looked at this and said, well, there's 5% here and 5% here, that means there's 90%. You could have done the same thing. You could have done the same thing. I would have found 90% of the 15,000 and worked from that area, but this is fine. We're going to work with the 96%. So part E, I added the 2 parts of the column that are not within the 5th and 95th percentiles. That's 596 numbers. Subtracted from 15,000 mean there's 14,400 numbers inside from here, here to here. And 14,400 divided by 15,000 is 0.9603. So part F says, use the values from part D, these 2 numbers, and E, this number, to construct a confidence interval for the median rental price. We are 96% confident the median rental price falls between $2,500 and $2,950 for all 1-bedroom apartments listed on the website for this city. And that is question 6. Now, I know I just went through that fairly quickly. It took me less than 10 minutes. But this is something that you should be able to do. Okay, we just got to look through, pay attention, and hopefully we can get there. I hope that helps. Good luck to you.